Hi, this is Alex from devstories.eu. Folium, episode 4 of 8. You click a marker on a map expecting a detailed breakdown, but instead you get a cramped, unreadable block of plain text. You might think map pins are only built for short labels, but you can actually embed an entire interactive data table or a mini chart right inside that pin. This is what we cover today: rich interactivity in pop-ups. By default, Folium pop-ups take a simple string of text, but they are built to handle much more. Consider a real estate map. When a user clicks a house pin, an address is not enough. You want to display a photo of the property and a clean, formatted table of housing stats. You achieve this by treating the pop-up as an isolated web page. First, you can pass raw HTML strings directly to the pop-up. By setting the parse HTML argument to true, you instruct Folium to render the string as structural web elements, rather than displaying the literal angle brackets on the screen. This allows you to include image tags, headers, and standard web formatting directly inside the marker. For more advanced layouts, you use a specific component from Folium's underlying framework called the Bronca iframe. An iframe creates an isolated, scrollable window within the pop-up. This is crucial when embedding complex structures because it prevents the pop-up's internal styling, or large images, from leaking out and breaking your main map layout. You create your HTML string, pass it to the iframe object, set a fixed width and height, and then pass that iframe directly into your pop-up. This workflow pairs perfectly with data analysis libraries. You do not need to manually construct HTML tables to display metrics. If you have a Pandas DataFrame containing the property statistics, you just call the standard Pandas to HTML method. You take that generated HTML string, feed it into your iframe, and your map pin now contains a fully formatted, accurate data table. You can push this further using the Folium Vega and Vega Lite classes. These classes allow you to embed interactive visualizations. Instead of passing HTML, you pass a JSON specification of a chart to the Vega class and assign that directly to the pop-up. Now, clicking the house pin displays a dynamic line chart of historical property values alongside the data table. Here is the key insight. Loading all this rich content creates a massive performance bottleneck. If your real estate map has 5,000 house pins and every pop-up contains a data table, an image link, and a Vega chart, the browser will try to render all 5,000 hidden structures the moment the map loads. The page will instantly freeze. To solve this, the pop-up object accepts a parameter called lazy. By setting a lazy to true, Folium does not inject the pop-up content into the web page initially. The map renders the markers, but the heavy HTML, iframes, and charts are entirely ignored. The browser only fetches and renders the content at the exact moment the user clicks a specific pin. This defers the computational cost, meaning a map with thousands of heavy, interactive pop-ups will load just as fast as a map with standard text labels. The true power of a web map is not where you place the pins, but how much context you can pack inside them without degrading the user experience. Thanks for listening. Take care, everyone.